Alright, hello and welcome. My name is Jason Welsh, and today we are going to be looking at tank maintenance. Tank maintenance is one of those key essential things that you do anytime that you run a new batch of stuff. You have to think about where your tank is at, what to make the settings at. So a lot of times I see, people struggle. They just kind of throw something in and then wish for the best. But in all actuality, what we do is we run a couple tests, see where it's at, change our chemistry, then wait, test again, and then do our stuff. Okay? At least that's what I do, and I get good results because of that. So you'll get to a point where you'll want to start doing that. Not right away, because in the heat of battle you just want to make copper plated things, right? And then after a while you get to the point where you're like, well, now I gotta start maybe thinking about, selling some of this stuff and running a business, and how do I produce the same level of quality across many things. And then testing becomes important. So that's what this video does. It gives you a test that you can run on a large tank, a big tank, a small tank, whatever. It's the same type of tests that you can do on your tank. And it all started with the wholesale test, and then I developed a test that you didn't need the wholesale test. All you need is these little tiny squares, and I'll get the information for you in the video. But at least now you have a video that walks you through just about every test that I do before I run a batch of electroformed goods. Alright, I hope you have fun with the video. Alright, step number 1. So, at some point, you probably had made your solution and you had your tank at a certain level. Okay? In this case, that was this line. So over time, what happens is water evaporates out of your tank. So your first step is to replenish the water in your tank. Use only distilled water. Number 2, any change that you make to a tank takes at least 30 minutes to actually take into effect. It doesn't happen instantaneous. So anytime, let's say I add water to it, I'll walk away, let that change happen, and then run a test. Before you run this test, make sure that your bar is clean. In this case, my bar is very dirty. You can use steel wool on it, but please make sure that you use a respirator mask when you do clean it off. Because copper particles coming off that is very bad for the respiratory system. After the bar has been completely clean, also make sure that only 2 inches of anode is down in your liquid. Okay? Only 2 inches of anode in your liquid. So the test I'm about to run is called the acid test, and what I do is I take a square. This is 1/2 inch by 1/2 inch with a little hole drilled in it. I get a really fine piece of wire. Okay, so this is actually 14 gauge wire, a strand of it. So I took 1 strand of 14 gauge stranded wire, and then that becomes my holder. So make sure this is real thin. Okay, and the reason for that is you want the maximum amount of amps to travel to this piece. So take your power source and just make sure that everything's zeroed out. So in this case I set voltage to 0. So hang the piece into the solution This solution should be agitated using a magnetic stir. This solution should be heated to around 77 degrees Fahrenheit, and I think that's 23 degrees Celsius, somewhere around there. So 77 degrees Fahrenheit, I know for sure. I use a fish aquarium heater to do this. Alright, let's go down to my power source, and what I'm going to do is run the test. So all I'm doing is setting voltage to get amps. So in this case, I'm going to watch my amps and set it to 0.2 amps. See how voltage is going up, and then amps is going up as I'm adjusting voltage. Point 2. Okay. And yeah, around that. So 0.2. Now notice my voltage. Now if you've been electroforming for a while, you'll know that 0.5 is very high to get to 0.2 amps. Okay? So if this number is too large to get to the amps, it's telling me that the conductivity of the liquid is a little off. So the pH level needs to be lowered in the solution. That's just based upon like years of doing this. So let's say if you're new to this, you always need two ways to test it. One, you can always, use this number and say, ooh, that's kind of high to get to 0.2 amps. The other method I'll show you is very simple, but you should know both methods. This is a pH meter. Okay, so I'm going to turn it on. Now, when you first start using one of these, you should know if it's calibrated. Alright, so a good way to do that is check it. Alright, and how do you check the pH meter? Very simple. You take distilled water and a crap load of baking soda and mix them in a beaker and stick this in there. That should be at 7. Like 7.7, somewhere around there. Do that first, and then make sure that you rinse off all baking soda, and then paper towel the very tip of it. Do that before you run the next part of this test. So test your pH meter. If your pH meter does not return a 7, or it's like 7.7 or around 7, then you need to recalibrate your pH meter. These do get uncalibrated from time to time, so you do have to recalibrate them. Okay, so I know this meter is calibrated because I checked it, and I'm dipping it into my tank, and it's 1.34. Now, I'm going to say that I want a 1 pH. Okay, so and there's a range. There's like 0.6 to 1 pH. Okay, and depending upon what fluid, this is an electroforming fluid. Okay, a plating fluid is going to be much higher than that, or lower than that actually. So it'd be like 0.3, 0.4, somewhere around there. So I'm going to add acid to this. Then I'm going to do another test with the pH meter, and I'm going to keep doing that. How much acid do I add? Well, you really can't overdose on it, that's for sure. So again, I just want the value of 1 pH. So I'm just going to add it wait 30 minutes, add some more, wait 30 minutes, add some more, until it reaches about 0.8 to 1 pH. That's as simple as that. Alright, so in the acid test, you'll notice that now I still have the same voltage, 0.58. But since I've added acid, now look at the amps. Nearly doubled. Okay. This is a great indication that I now have enough acid. Okay, but again, since I have a pH meter, that's a good way to double check the test. And sure enough, now it's hovering around 0.96 pH. So that's a way that you can use voltage to check your pH level. Very simple. So now let's go on to the next part of the test. Alright, so this piece is now ruined. It was only meant to be used for a test piece. Okay. Since it's been spiked to like 0.5 amps, it's now, like outlived its use. We put a new one in and set it back to 0.2 amps. Once I have the new test square in, I'm just going to set this to 0.2 amps. So, I'm going to let this set in the liquid for about 15 to 20 minutes, and then I'll come back and look at the plate, and I'll share with you what I'm looking at on the plate. Alright, so if your piece turns out like this, that's a good indication that you need brightener. So we have to rule out brightener out of the equation. So what you do is you add your brightener, and there's many different variations of brighteners, but one of the ones that most people use is the Rio Grande Minus. Again, you don't have to use this. Let's say I was just to run a piece. The piece at this point might turn out really good. I could just run it and then tumble it. Okay? But this is a systematic video. So at this point, if you don't see shine and you want shine, you have to add your brightener. Okay? I'm going to add brightener to the solution, and then I'm going to rerun the test. Remember to wait 30 minutes before you run the test. Okay? The test again is at 0.2 amps. Alright, congratulations, you have a shiny plate. So the next step is clarity. Okay? If you look at this liquid, I cannot see through it at all. Okay? If I hang something in there, look at the clarity of this liquid. Wow, right? And the clarity of this liquid. The clarity, especially with new electroforming solution, is a bit murky. In order to clear this up, I'm just going to run it through a filter. In fact, I'm just going to use coffee filters. I'll put about 3 of them together and then run the whole solution through 3 coffee filters. Coffee filters are about 1 micron, somewhere around there. So I'm just going to stack 3 of them together, and that would give me the sufficient filtering capabilities. You don't have to carbon filter at this stage, but let's get the clarity of this liquid back to where it should be. Alright, so here's my setup. A funnel, I actually sacrificed and only have 2 filters because I need another filter for coffee later. So yeah, there's should be 3 filters here, but here, my milk jug. Notice that the funnel fits inside the milk jug. It's not sitting on top of it. Therefore, when I pour liquid in it, it's not going to spill. Alright, so safety first. These funnels are made for oil in a car. They fit perfectly inside the milk jug lid. Sweet. So this is a great way, a very intro way to filter a solution. So I'm just going to pass it right through this and we'll check the clarity. If yours is airtight like mine, like right here, this is a really good seal. Poke a hole right about there, just a small little pinhole to let air in, or it will take forever. Yay. Alright, now that the clarity of the liquid is better, we're going to run another test. This test you don't have to run. You can skip to the next test if you want. But this test allows you to see the current density of the current solution. So if you know the current density, you'll know what to set your pieces at. Okay, so this is a little bit more of an advanced test, but let's say I want to know what to set my meter at. 0.1 amps, 0.2 amps, 0.5 amps. What do I want to set it at? What would be the optimum amperage? Okay, so that's what this test is all about. If you don't want to know how to run this test, I would skip ahead in the video. So to run this test, all you have to do is put a test piece in, just like before, and I want you to run that test piece at 0.1 amps. Take that off the hook and rinse it real good. Set it off to the side. Then you need to repeat the test at 0.2 amps. And then wash that one out and repeat the test at, let's say, 0.4 amps. So skip ahead a little bit. I want you to set each one of those on a piece of paper, and I'll have mine ready, and I'll show you how to interpret the results. Each test should be ran for about 15 minutes. Okay, so here's the results of that. And you can see I ran a few more just to kind of show you, and feel free to run as many as you want, really. This is a good way to be able to learn your solution. Okay, so this is the current densities in my tank with that solution. Alright, and these represent the amps, 0.1 amp, 0.2, 3, all the way up to 1.8, and 1.8 is when it started to burn. So I have this full range to play with if I want to. But let me show you some things about playing in this so that you can identify these in your own tank. If I can get everything to just, let's see, what would be better is maybe go like this. Alright, sweet. Okay. Now, the lowest is 0.1. Just point out a few things. So when I bend this wire, this is where it started to coat. And when I bend it, you can see as I bend it, it doesn't crack. Okay? So at 0.1 amps, I have a copper that can be bent, without any cracks. And it's shiny. Cool. At 0.2, the copper starts getting brittle. Okay, 0.2, but it's still shiny. 3, I actually left in my tank a little bit too long, but you can see it's super shiny, but very brittle. Point 4, it starts to lose its shine. And I can bend it, but it still will crack, but it won't break off. See, these tiny observations are very important, because if you want to build like a ring, here's 0.8. You can see a heavy texture buildup. In fact, look at the texture here. This is just 15 minutes. Huge texture, right? And it's almost a powder. And then of course, 1.8 would be just disintegrated, burnt. Yeah. Now, if I was to build a ring, what copper would I use? Well, I would probably use the 0.1 amps per inch. Okay? And as long as I kept it at 0.1 amps per inch, I would still get that bendable copper that's really rock hard, but still bendable. Okay? Ductile, I think they call it. Now, let's say it's like kind of playing a guitar. So, I want texture too. Well, there's not very much texture on 1, but there's tons of texture on 3. So, during the process of electroforming, I could start at 1, then for a little bit of time, depending on however you play this note, I can go to 0.3 to get some texture, and then I can go back to 1. And that's how I build texture. And knowing the current density range and what happens in its range, you can add texture and still keep a very strong piece. So if I build bracelets, for example, like these, okay? These have to be really strong. They have to bend just a little bit. But I still want the texture on them. So before I do any kind of work like this, I know to run this test, and then I know what the outcome is sort of going to look like. So that's the importance of that test. And that ends that test. But there's still some to learn from this test. So we're going to end the current density range test, and I'll show you what else you can learn from it in the next test. Fluoride test. So at this point you can use all the other tests to do a chloride check. Very easy. The first thing you have to do is check your anode. Anode color is black. Okay? This is a great indication that you have chloride. Now, how much chloride, right? How much chloride do I have? Well, another indication, and I don't know if I could put that, I'm going to put it over to the side because I can't do that with one hand. it down there for right now. Also, if you look, see how it's a little bit brown right there? So it's dark right here, but I could still see some brown around the outside edges. Okay, so that's the first part of the test, is a visualizing of the anode. It has to be pipe. You can't look at your wire. Wire will not work for this test. You always have to use copper pipe for it because it contains phosphorus. So, black, good. A little bit of brown though, okay? On these wires, from the current density, you can see that they have lines. See how those are spaced apart almost perfectly? All the way down, right? On 0.3 it didn't show. No, 0.4. This one has some. Okay, so that one. So it really showed at 0.8. Again, there's two things it could be, either low chloride or low on carrier. Okay? Chloride is kind of a hard thing. If you put too much in your tank, it could do damage. So I'm going to aim at carrier. Okay? Carrier would be something like Miralax, for example. And you can use Miralax with Rio. It's no big deal. So I use it all the time. So Miralax. Miralax is this substance is right here. It's also called osmotic laxative. So, Miralax. Yeah, you've seen this before, especially if you're in America. If you're in other countries, you have to look for that. You can also look for just polyethylene glycol. The number is the weight of the glycol. So you can ignore the number altogether, as long as it's polyethylene glycol. So in this case, this is a really thin glycol. It's 3350. If you had a 400, it would, I believe it'd be thicker, but it's still the same substance. So you can buy this just plain online. Okay, cool. So how much, right? Well, you can't. This is one of these things that you can't hardly overdose it all in your tank, I've noticed. So I always start out with a low value. I add $30 milliliters by volume to 150 milliliters by volume distilled water. I mix those together and I'll add that whole to 1 liter. Alright, so that sounded confusing, but I'm just going to do it in front of you because it's just super easy to do. So, Miralax, 30 milliliters by volume. Beaker with a stirrer at the bottom. And then distilled water. Hold on. Now it doesn't really matter. I mean, like, I could add 150, but what happens is, like, I use 150 because I know the solubility of this is really nicely distributed to 150. It's not oversaturated, it's not undersaturated, it's just like the perfect saturation for this glycol. That's why I use 150. You could stir this with a stirrer. You could shake it like this for a little bit, but when it's done, it should turn crystal clear. That's when you know it's ready. And if you're running out of room in your tank, it's best to take some out of your tank into another vessel and add this. Cool, so all these bubbles will be gone too. I'm going to use a stir for this. I'm going to add this to my tank and then rerun the test after 30 minutes. Alright, so here's the results of that. Again, carrier and chloride are kind of a test you have to do together, in my humble opinion. So we don't want to add chloride first. We want to add carrier first, because carrier is non-destructive. Okay, you can have a lot of carrier in an electroforming solution, but you can't have a lot of chloride. So how I gauge this test is, did I see change? And in this case, no, I did not see change. And if I did see change, that means I just back off because the carrier worked. If I don't see change, that means I need chloride. Easy test, right? Sweet. So each one side by side. In this case, I'm going to add chloride, and this ends the carrier part of the test. So, chloride. I only add like 1 drop into the biggest tank at a time until I'm happy. And every time I add 1 drop of this stuff, I wait 30 minutes per drop. It's that destructive. So I'll show you what that is, and then I'll add a drop and then run my last test. Hydrochloric acid, 37%. Okay, so don't use muriatic acid, use hydrochloric acid. Muriatic acid has sodium and brine in it. You can still use it, but later on you'll regret it. Hydrochloric is pure. It doesn't have the sodium and brine in it. And it doesn't have the iron in it either, so it has, like maybe some sodium, but very, 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 very low compared to muriatic, which is a dirty hydrochloric acid. Cool. So I'm going to add 1 drop, and when you first start out your electroforming solution, you usually use a lot more than that, but as time goes on, you deplete it, or just things happen and you need more. Cool. So I'll show you the results of that test. I'm going to run that test at 0.3 after I add the drop. Alright, so here's the end result of the chloride. Once I added the chloride, you can see that tamed down all the little nodes. They're getting there. I left this one in the bath a little longer, maybe an hour, somewhere around there. So, test it up. It's not bad. I had to go all the way around to get it to break. This was at the 0.3 still. If you remember the other 0.3. So I couldn't even bend it that far. Definitely shiny. So that's it for all the tests. I mean, there is one more, but you'll definitely know when you have this wrong. So I'm going to end the chloride test here. I'll show you one thing that'll show you what you should do in case you have a contamination issue. Alright, so if you put your square in and you start getting these things, okay, you have steel in your tank or iron. Usually comes in from either hard water, or it can come in from like dirty acids. It also can come in from contaminated copper sulfate. There's so many different places they can come in, but the only thing that I've noticed that you can do is two things with this. You can either carbon filter it, which I do have a video on how to carbon filter, or you can just plate it out. So just put one of these in there and plate the crap out of it, and it'll grow some fantastical things for a few days, and all of a sudden it'll clear up and become normal again. So that's the other way to do it. Metal has to come out. It'll plate itself out. Cool. So I will save you the time of watching that because I don't have a contamination issue. I can only show you what it looks like. Alright, so you have addressed chloride, addressed everything else, and you now still have dullness in some areas. Okay? The current density here between 0.1, 0.2, and 0.3 are all shiny. That means everything's good. But if 0.1, 0.2, and 0.3 are like dull going across here, and you've addressed acid, you've addressed pH, you've addressed chloride, that means you have too much copper sulfate in your solution. Okay? So it's pretty easy to fix. If this tank had too much copper sulfate in it, all I would have to do is drain it. And I always tell the people I'm helping 2/3 or 1/3, drain it 1/3 of the way. Alright, so just take 3,000 divided by 3, and then, whatever that number is. So let's say it's between here and here, drain that liquid out into a different vessel. Keep it off to the side. You could use it. Maybe you can make a small tank. And then fill it with distilled water. Then you have to run all the other tests, like the acid test, everything else, because once you add that much water into a tank, your acid levels are probably going to drop. So you'll have to run the acid test. And then also, if you add that much water, your brightener level is probably going to drop, so you're going to add more brightener. So it's the very last thing you address, and it's one of the things that you have to rebalance everything once you do it. One last thing, this will be really dark. I mean, like, this liquid's pretty easy to see through, but your tank will be like a really, really, really dark blue if you have too much copper sulfate. The last great indicator of too much copper sulfate is crystal growth. If you have a lot of crystals growing in a tank, you have too much copper sulfate in that solution. Alright, this ends the video of testing. I hope you enjoyed the video. It was rather long, but there's a lot of information here that you can just kind of replay on different events if they happen within your tank. So it's kind of like the encyclopedia of electroforming, maybe, in video form. Alright, have a good one. Until next time.